Welcome to Pharmaceutical and Medicinal Chemistry, Module 4 CNS Drugs, Chapter 4.4 Synthesis and Therapeutic Action of Paracetamol. Learning Outcomes. At the end of this chapter, you will realize the therapeutic importance of paracetamol drug. You will be able to understand the stepwise mechanistic pathway for its synthesis. You will be able to comprehend the pharmacokinetics and pharmacodynamics of paracetamol and also enlist its indications, contraindications, and adverse effects. Contents. This chapter contains introduction of paracetamol, its synthesis, properties, routes of administration, its uses, preparation and dosage, pharmacodynamics, pharmacokinetics, contraindications, and adverse effects. Introduction. Firstly, paracetamol is a non-opioid analgesic and antipyretic which is used to treat fever and mild to moderate pains. The chemical structure of paracetamol and the molecular formula is C8H9NO2. The IUPAC name is N4-hydroxyphenyl estamide. The common name which is widely used is acetaminophen or parahydroxyacetaminide. The common brand names of paracetamol include Velpar, Dolo, Calpol, Critpur, Tylenol, and Panadol. Synthesis of paracetamol. The starting material is phenol. Phenol undergoes nitration and forms a mixture of orthonitrophenol and paranitrophenol. The paranitrophenol so formed undergoes reduction in the presence of iron and HCl and forms para-aminophenol, which undergoes acetylation in the presence of acetic anhydride and forms para-acetaminophenol. Next comes the properties of paracetamol. Paracetamol, it's a white odorless crystalline powder which is slightly bitter in taste. Melting point is around 169 to 170.5 degrees Celsius. It is very slightly soluble in cold water, but it is soluble in hot water. It is freely soluble in ethanol, acetone and chloroform and insoluble in diethyl ether. Routes of administration of paracetamol. It can be administered orally through mouth in the form of a syrup, tablet or suspension. It can be injected by intravenously or it can be taken in the form of a suppository through rectal. Uses of paracetamol. As paracetamol is an antibiotic and an analgesic, it can be used to reduce headache, muscle ache, body ache and toothache. It is very effective in reducing fever with various conditions such as infections and inflammatory illness. It has been included in the cold and flu medications to provide relief from associated symptoms such as fever and body ache. It can be used as a part of management of pain associated with osteoarthritis and rheumatoid arthritis. It can also be used for injuries such as sprains which can be managed by paracetamol. So students, next is the preparation and doses. The dosage of paracetamol is 500 mg for adults. It should not exceed 4 grams per day. Injection paracetamol must be given intramuscularly and intravenously. Pharmacodynamics. Paracetamol primarily acts by inhibiting the enzyme cyclooxygenase in the central nervous system. It mainly works in the brain and the spinal cord, reducing the production of prostaglandin which are involved in the pain and the fever. It acts on the hypothalamus of the CNS which plays a key role in maintaining the body temperature, and supplying blood to the peripheral nervous system also increases. Increased supply of blood causes sweating, and sweat on evaporation causes cooling and thereby reducing the temperature of the body. Pharmacokinetics. Paracetamol is a phenol-containing drug, which is an anesthetic drug which can be easily absorbed in the small intestine, and it's going to reach the peak plasma concentration within 1 to 2 hours after oral administration. It has been widely distributed throughout the body, crossing the blood-brain barrier. It is being metabolized in the liver to para-aminophenol. It can be excreted through kidneys in the form of urine. Contraindications. It should be avoided for the patients with issues of liver damage, alcohol consumption, allergic reactions, G6PD deficiency, pregnancy, and breastfeeding. Patients with severe liver disease, hepatitis, or cirrhosis should not take paracetamol as it can exacerbate liver damage. Alcohol consumption. Chronic alcohol use combined with paracetamol increases the risk of liver toxicity and should be avoided. Allergic reactions. Individuals with known allergy or hypersensitivity to paracetamol should avoid its use. Paracetamol may cause hemolysis in individuals with glucose 6-phosphate dehydrogenase deficiency. Though paracetamol is the safest drug and can be given to the pregnant women, prolonged use or high doses of paracetamol should be avoided, especially in the first trimester. The adverse effects of paracetamol are liver damage, kidney damage, skin rashes, hives, difficulty in breathing, nausea and vomiting, drowsiness, abdominal pain, yellow eyes or skin jaundice, dark clay-colored stools, diarrhea, blood and cloudy urine. What we have learned from this chapter. In a nutshell, we have understood the mechanistic pathway for the synthesis of paracetamol, its therapeutic importance along with the indications, and realized the contraindications and adverse effects of the paracetamol drug. Thank you.